Installing electrical boxes requires adherence to safety codes and best practices to prevent hazards and maintain structural integrity. Cutting into structural elements like wood beams to accommodate an electrical box can compromise the beam's load-bearing capacity, potentially leading to structural failure over time. The National Electrical Code, or NEC, sets standards for electrical installations to ensure safety. Several aspects of this type of installation may violate the NEC. Firstly, the NEC addresses the physical protection of conductors. Running electrical wires through holes drilled in wood framing members is permitted, but specific rules govern the size and placement of these holes. The NEC requires that when holes are drilled through wood studs, joists, or rafters, they must be far enough away from the edge to provide adequate protection against nails or screws that might be driven into the wood in the future. If the wires are too close to the edge, a metal plate is needed to protect the wiring. Secondly, the NEC specifies the requirements for securing and supporting electrical boxes. Electrical boxes must be securely fastened to a structural member of the building. Simply carving a hole in a beam and fitting the box into it may not provide sufficient support and could allow the box to move or become dislodged over time. This is especially true if it is a plastic box. Thirdly, the NEC covers the proper installation of electrical boxes in wet or damp locations. If the location is considered damp or wet, the electrical box must be rated for that environment and installed in a way that prevents moisture from entering the box. It is not possible to know based on this information. Fourthly, the NEC mandates proper grounding and bonding of electrical systems. All metal electrical boxes must be grounded to provide a path for fault current to return to the source, stripping a circuit breaker or fuse and preventing electrical shock. The grounding conductor must be properly connected to the box and to the grounding system of the building. Fifthly, the NEC contains rules about workmanship. All electrical work must be performed in a neat and workmanlike manner. This means that the installation must be visually appealing and free from defects that could compromise safety or performance. Carving a rough opening in a beam is not considered workmanlike and could indicate other underlying issues with the installation. Sixthly, the NEC regulates the use of approved materials and equipment. All electrical materials and equipment must be listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all, to ensure that they meet safety standards. Using non-approved materials or equipment could create a fire hazard or electrical shock hazard. When installing electrical boxes, several precautions must be taken to ensure safety and compliance with the NEC. Firstly, always disconnect the power before working on any electrical circuit. This will prevent electrical shock. Secondly, use the proper tools and equipment for the job. This includes wire strippers, screwdrivers, pliers, and a level. Thirdly, follow the manufacturer's instructions for installing electrical boxes and other electrical equipment. Fourthly, ensure that all electrical boxes are properly grounded and bonded. Fifthly, inspect all wiring for damage before making connections. Sixthly, never overload electrical circuits. This can create a fire hazard. Seventhly, obtain necessary permits and inspections. In most jurisdictions, a permit is required for electrical work, and the installation must be inspected by a qualified electrical inspector to ensure compliance with the NEC. There are alternatives to carving into a structural beam. Firstly, surface mounting. Instead of recessing the electrical box into the beam, it can be surface mounted directly onto the beam. This avoids compromising the beam's integrity. Use appropriate surface mounted boxes and ensure they are securely attached. Secondly, conduit. Run electrical wiring and conduit along the surface of the beam. This protects the wires and allows for easy access for future maintenance or modifications. Conduit can be aesthetically integrated with the beam using appropriate fittings and supports. Thirdly, relocation. If possible, relocate the electrical box to a nearby wall or another suitable location that does not involve altering the beam. This may require rerouting the wiring, but it ensures the structural integrity of the beam. Fourthly, consulting a structural engineer. If there is no alternative to cutting into the beam, consult a qualified structural engineer to assess the impact on the beam's load-bearing capacity and recommend appropriate reinforcement measures. This is particularly important for load-bearing beams. Fifthly, using shallow boxes. Use shallow electrical boxes that require minimal recessing into the beam. This minimizes the amount of material that needs to be removed from the beam, reducing the risk of weakening it. Sixthly, reinforcement. If it is necessary to cut into the beam, reinforce the beam with steel plates or other suitable materials to compensate for the loss of strength. The reinforcement method should be determined by a structural engineer. The proper installation of electrical boxes is essential for electrical safety and the structural integrity of a building. Cutting into structural elements like wood beams to accommodate electrical boxes can have serious consequences, including weakening the beam and creating a fire hazard. Always follow the NEC and consult with qualified professionals when performing electrical work.